Homework for Chapter 11 should go to your left, please. So the equations that we were actually looking at the end of class on Monday like this one, that's a model. It's an estimator because we had a data file and we said, hey, we're going to try and figure out the line we want to use to find a relationship between the square footage of my house and the price of my house. And this is a regression model, which means we're estimating things. That 125,000 there, that's an estimation for what we believe the true intercept to be. If you went out and you gathered every piece of data and tried to draw the best line, there should be a number. This is an estimate for it. Same thing with the 150. That's an estimate for a slope. Every additional square foot of area in the house causes the price of that house to go up $150. But because this is an estimation, there could be some error in here. We're going to make the assumption that our error term is normally distributed, that it's got an average of 0, and that the standard deviation of the error is the same no matter where we are in our data file. And if that's the case, then this equation allows me to predict a y value for any given x. In this case, it allows me to predict a home price for any given square footage. Now, again, I can look at a data file and I can say, here is a bunch of, that's not the right one. This one is based on the price of the house versus the income of the person buying it. So if you're in this city, the median income for people in that city, I wonder if Pittsburgh's on the list. Nope. So let's say you live in Cary, North Carolina. Median income in Cary, North Carolina is $77,000. The median home price is $207,000. So here's my question. Is home price related to income? Are home prices more expensive where people make more money? Are they cheaper where people make less money? Maybe. How would I even start to find out if there's a relationship between these two ideas? Do what we did Monday, which was make a scatter plot. Let's start there. So, insert scatter plot. Oh, that's the wrong kind of scatter plot. Let's get rid of that. Let's highlight the two pieces we want and then insert the scatter plot. That do it right? Yes. There's my scatter plot. Now remember, the horizontal direction, that's income. The vertical direction is house price. So let me add labels. So I remember what's what. Is there a relationship? Do you think it is strong or weak? Do you think it is positive or negative? Positive. As home prices go up, as income levels go up, home prices are going up. Which means that if I do an equation, there should be a positive slope for that equation, right? Do you think this is a strong relationship or a weak relationship? If I do the correlation, should it be close to 1 or closer to 0? If you can see a trend, as opposed to it being scattered all over the place, I would expect it's probably closer to 1 than it is to 0. But it might not be very close to 1 because this is a fairly broad track of data. The closer we are to 1, the tighter that group should get. Think back to the pictures we looked at on Monday. The leftmost pictures are positive 0.9 and negative 0.9. Those are pretty close together. 0.5 and negative 0.5 are spread out a little more. And 0, whatever. So, I can say, I think there's a relationship. It should be positive, more strong than weak, but probably not really strong. If I were to draw a line, some of the dots would be on the line, some of the dots wouldn't. Yes? So, for each dot, there's a distance straight up and down to the line. Our line for each data value, and I'm going to call that xi and yi because I don't know which one it is. Could be the first one, could be the 13th one, could be the 73rd one, it doesn't matter. There's a predicted value, which they call yi with a hat on it, which I was making up. That symbol is called a hat. Y hat is an estimation. I think that would be the answer. The difference, the length of that line, is called the residual. And in a sense, that's an error. That's how far off our estimator is from the actual value. Some texts use the absolute value. Some texts use the hat minus the original value. We're using the original minus the hat, but it doesn't matter all that much because most of the time, we're going to square this. I would like to know how good my line is. And my goal should be to have as little error as possible. That means I want these residuals to be as small as I can make them, yes? I would like, that's a really problematic spot, isn't it? But if I go back and I look at that picture we were looking at for the home prices, I don't know where the line's going to be. Some of these might be really close, some of these might be really far away. I don't know. Finding the least error is a minimum problem. Minimums are things we do in calculus. So if I want to actually do all of this, there's a calculus problem. The calculus problem results in a formula about this big that is absolutely gross and disgusting. I don't want to do it. Excel will do all the calculations in the background and just spit out the answer for me. So right-click somewhere on the data. Again, this is in our sample in-class example section. This is number 13 for this section. But if I right-click anywhere on the data, one of the options there says add trend line. The trend line is the line which minimizes the residual error. So I'm going to add that trend line. It drew the line. Ta-da! Now, some of these have bigger residuals, some of these have smaller residuals, right? You can tell some of these are pretty close. Some of these are pretty far away. Residual error is straight up and down. In order to minimize, well, negative distances where the predicted value is above shouldn't count against me more than positive values where the predicted value is below. Remember, doing y minus y hat. If I square and then take the square roots, wait a minute, where have I seen that before? Square and then take square roots. Say again? The standard error. The standard deviations, right? With variance, we took all the stuff, we squared it, and then to take the square root to get the standard deviation, to get the standard error. Aha! If I add up all those deviations, I square them first, and then I take the square root. I'm really doing the standard deviation on the error. And then I do a bunch of calculus to make that as small as possible. But since I squared, we call this line the least squares line. The least squares, or the regression line. Now, what's interesting here is that this line does not do anything about cause and effect. It doesn't tell me that higher income causes increases in house prices. It just says that they're correlated. They're related to one another. Doesn't tell me how much yet. I didn't do the correlation coefficient. I could. It's a separate calculation. But you'll notice it brought up all this garbage over here, didn't it? What do you see over here in this side panel? I see a bunch of things. The first of which is I only wanted to do a line. But at the top here, there are regression options for lots of other different kinds of data. Financial data is not often a straight line. Income gets bigger and bigger and bigger exponentially, right? Market share does that sort of exponential behavior. And then at some point it tapers off again. So we get all sorts of different kind of regression calculations. This course is only going to examine linear regression. All the rest of them work the same way, that just the algebra is uglier. I didn't name it. I didn't do anything about forecasting. But down here at the bottom, these bottom two options, one second to the last says display equation on chart. I don't have to do any of the calculations to figure out this regression equation if I just click that box. Okay, people, I need your help. Just like Monday. What the hell does this equation mean? That's a slope and an intercept, yes. But now let's put it into the setting of this problem. An intercept would be a spot over there on the y-axis, right? And that would be a house price when the median income of the city would be 0. Does that make any sense? You know, a town where people don't make anything? So the intercept only sometimes has a meaning. And in this case, that doesn't make any real sense. So that 51.24, that's not helpful to me in this problem. The slope, on the other hand, 2.6 rounded, 2.61. What the hell does 2.61 mean? That is the slope. But again, in this problem scenario, slope is change in y and change in x, right? I remember my algebra class, no matter how long ago it was. Y is, on the graph, y is house price. X is, so every time my income level goes up 1 unit, in this case $1,000, my house price should go up 2.6 units, $2,600. So there's my meaning. That 2.61 is $2,610 increase in house price for every $1,000 more in income in that city. Fabulous. I love it. I don't have to do the work. That's the best damn part. All right, wait a minute. We go back to the line, and you see I've checked that display equation. There is a correlation coefficient. We know how to calculate it. I can actually do that right over here. Let me put it down at the bottom. I can write equals CORREL. Parentheses, it wants the x values first, comma, the y values. There's my correlation coefficient, 0.583. Closer to 1 than 0. All right. Back here on my trend line calculation, oh, wait a second. I'm going to write that this is my correlation coefficient. Back in chapter 4, which is the first time we encountered correlation, we gave it a name. What letter did we call that? It was R. So I'll actually write that down here at the end. R. Oop. Made it a trademark R. That's not what I want. There. Back on my trend line setup, if I click on that trend line, what's the last option say? Display R squared. Grab your calculators for me. What is the square root of 0.3399? The square root of 0.3399 is 0.583. That's our core. This R squared is our correlation coefficient squared. A bunch of squaring and square rooting going on. But they give me that. I didn't have to calculate it separately. Hot damn. All right. I want you to understand that in order for me to calculate all of this stuff by hand, first I have to calculate this, multiply all of the residuals, divide by their squares, and then I have to figure out the intercept. And I have never, ever in my entire adult life done any of this crap by hand, ever. As a matter of fact, You can do regression on here. It's under the stat menu. If you hit stat under calculate, there's our one variable statistics. Number 4 is linear regression. So if you entered your data in the lists that you can put, where it says edit, you can edit a list. You can put your data into one of these lists. Lists of data, see? You could then do linear regression right in here. So literally, I have never, ever done this stuff manually. Do I want you to do it manually? Hell no. Most of the time, either I'm going to give you that information, or I'm going to give you the more detailed version that Excel can do. But before we get there, that R, our correlation coefficient. Why wouldn't they give me R? Why did they give me R squared instead of R? It turns out that correlation squared, that R squared value, is often called coefficient of determination. It determines how much of the variation in home price is explained by variation in income. It's an ANOVA idea. Son of a... That's an ANOVA. And it's measuring how far apart the residuals are, how big they are, compared to their distance horizontally. And this number, right now, let's call it 34. 34% of the variation in home price is explainable just by variations in income by city. What's the other 60-some-odd percent? Other things, real estate value, population, whether that city is growing or shrinking. There are all sorts of other factors, right? But this is referred to as simple regression because it only has one factor, like a one-factor ANOVA. Only trying to tie house price to income, not trying to tie it to anything else. If I want to do more, there are ways to do multiple factor regressions. Next chapter, which you'll notice is not in our syllabus. So, I've got a clear understanding that while house price changes based on the income of my city, it's not the only factor that determines that, and only about 34% of that variation is determined by our variation in income. That's why we call it the coefficient of determination. Questions? The more you study, the better your exam grade should be, right? Let's check. This, by the way, is the sample problem in the text. On page 470. They did all the calculation by hand. I ain't doing any of that crap. So all I did was take these two columns and put them into Excel. How long did you study? What was your exam grade? So here's a scatter plot. put the trend line on it, and I put the equation. Let me make it bigger so it's easier to read. Now here's a question for you. Does the intercept here have meaning? What would it mean, Colin? If you studied 0 hours, X being 0, the number of hours we studied, I would expect a score of 49.4. That's what my model predicts, at least. What's the slope mean? Aha! But it's not just if you study 1 hour. For every extra hour you study, I should expect a 2% increase, 1.96, increase in your grade. Please notice it doesn't say just the day before. It didn't tell me how long they took to do all this studying. I mean, some of these people studied for 19 hours. I hope they didn't do that the day before the exam. I'd like to sleep and breathe and eat and all those other things. But now I have the ability to say, okay, for every additional hour studying, you should see a 2% improvement in your grade. How strong do you think this relationship is? I would need the correlation, wouldn't I? And I would like the coefficient of determination. I'd like R and R squared. Well, I can get both of those. If I hit that trend line, right click on it, format trend line, click, here's my R squared. Okay, what's the square root of 0.3941? .62, again, bigger than a half, closer to 1 than it is to 0. So what's not terribly weak, not great in terms of strength, but that R squared being 0.39 means that only 40% of your grade is solely attributable to how much you study. What's the rest of it? Other stuff, right? General knowledge. Is this a class you're strong in, a class you're weak in? It's more than just how many hours did you study for this exam. It's all the rest of it. And 10% of your grade depends on that stuff. I did write up the calculations for you. Here they are. I didn't do them by hand, but I did all the different pieces that they show in that table on page 470. But rather than me do all of that by hand, I let Excel do it all for me. Now notice, there are a bunch of abbreviations here. SSE, SSR, SST. Those stand for sum of squares, of error, of regression, and total. Just like in our ANOVA, we added up a bunch of stuff, squared stuff, added it again. That's what we're doing here. That. It's literally not helpful for me to see under the hood at this point. We can do it, but really there's no reason to when it's basically done for me right here. It is the interpretation. Okay, please notice that no one over there studied 12 hours. If I study 12 hours, what should my expected grade be? Well, let's find out. How would I find out? Take my equation, put in 12 for x. There you go. Click. 12 times the slope was 1.96. I got to keep flipping back and forth here. 1.9641, 1.9641 plus 49.477. So I've typed in my value, added everything on, 477. I'd expect a 73. Assuming my model is accurate, right? Now, that's an assumption. And it's based on how good of a fit this is. It would be nice if I could figure out somehow a way to determine, other than just looking at that R number and that R squared number, going, all right, it's kind of a good fit, how much error there is here before I do that. If you earned money last year, will you earn money this year? 2 consecutive years of portfolio returns. All right. I'll make a scatter plot. I'll put a line and an equation on it. Two questions. Very similar to the questions I asked last time. Does the intercept have a meaning here? What does it mean, Katie? In geometric terms, yes, but in terms of this problem setting, let me think about it that way. If I'm on the y-axis, that means x is 0. If x is 0, that means last year my return on investment was nothing. But you would expect then that I should make 11% this year regardless. I should start there. What's the slope mean? At 0.458, what does that mean? Per what? That's how much it goes up per. Slope is change in against change in, right? We think of slope, it's always got units like miles per hour, feet per minute, percentage per percentage in this case, right? Rate of return against rate of return. It goes up by almost 0.5% for each additional percent you made last year. So every increase last year corresponds to a smaller increase this year. Every additional percent I earned last year causes me to go up a little less than 0.5% this year. All right. What's R squared mean here? 0.2823. That information tell me. Please understand, 99.9% of the time, if you are doing statistics for your company behavior, nobody wants to see this. They want you to explain it to them. Most of your managers, your vice presidents, your supervisors, they're not math geeks. I am in a very lucky situation. My boss, Sister Susan, is a PhD chemist. She can geek out with the best of them. But if I have to go to the board of trustees, not many of them are very mathy, geeky people. So I have to put this into terms that they will be able to relate to. I have to turn it into, what does this mean in the setting I'm in? So what's that 2823 mean in the setting I'm in? So 28% of the variability is only attributable to what we did last year. That means that 72% is attributable to other stuff, right? I don't know what these portfolio differences are. Maybe one of these is a healthcare portfolio. One of these is a semiconductor portfolio. One of these is an agriculture portfolio. One of these is a commodities portfolio. And maybe it's market effects in other fields. There's something else going on. The higher R squared is, the more strength there is in the connection between these two things. There's more direct attribution. Every year, by the way, I did this in the very first day in class. Every year, I calculate grades versus absences. And I run a regression to see if more absences mean lower grades. And then I check R squared. And almost every year, R squared is about 10, 12, 15%. Which means that variability in grade is very loosely related to how often you show up. It's more often related to other stuff as opposed to attendance. But I want to know that. And that's why the very first day I say, I'd like to think I make a difference, but I have to check every year to see if I do or not. Questions? All right. I did a bunch of squares. I did a bunch of square roots. I did a bunch of analysis. And I was able to say, how close is this? What are my residuals? That means there's some error baked in here. I should, as Owen said, I should look at a standard error. If I'm going to do a standard error, I'm going to do a standard error calculation, which means I have degrees of freedom. Is n minus 2. Why is it n minus 2, not n minus 1? There are two different things that we calculated to figure that out. I need to take one out because I'm doing the standard deviation. It would normally be n minus 1, but I'm using the y hat. That means I calculated something else. I have to take out one more. I never, ever do this by hand again. But that means there all of a sudden does come a place where I think I should look under the hood more closely. So let's go back and look at this problem. I have shipping costs. Instead of making the scatter plot and getting the equation that way, I'm going to go back to my analysis tool pack. I'm going to go to data, and I'm going to go to data analysis. This is where my ANOVA, where my all sorts of stuff are. I see correlation. But if I scroll down further, I see regression. This actually does generate an ANOVA table. It gives me the under the hood look. All of the pieces, and that includes my standard errors. So, I want to do this. Tell me where your Y's are. Well, it tells me, well, Y's are here. Tell me where your X's are. It says X's are here. Yeah, there are labels in the first row. And now, I'm going to do a confidence interval and a confidence level. I'm going to do an alpha. I'm going to check my errors. Confidence level, 95%. Do this. Oh boy. The hell is this?
There's a lot of stuff here, man.
All right. Let me see what's going on here. I see up at the top there a row that says R squared. It gave me R squared. Now, underneath that is something that says adjusted R squared. We'll talk about what the adjustment is in a little bit. But that number is R squared, 0.67. Wait a minute. Square root of that. The number right above it, the R. 0.67, that means 67% of the shipping cost is related to the number of orders. Okay. There is my standard error. It gave it to me right away. I didn't even have to do anything. It just spit it right out. Again, I need to interpret this in the light of the problem. That's big, but it's not huge because we're looking at numbers that are in the thousands. Okay, so that's not outlandish. We could do a percent error if that would make you more comfortable. Then there's this ANOVA table. And my brain goes back to the stuff you just gave me for homework. There's a null hypothesis and an alternate hypothesis, and I need to know whether or not I'm right here. So, the other thing that would help me here is knowing what my regression equation actually is. The very bottom two rows are doing an F-test, an ANOVA, on did my choice of slope affect anything? Did my choice of intercept affect anything? The first two numbers in those bottom two rows are the intercept and the slope. So what's my equation in this problem? I'll make the numbers bigger. Almost. There's one thing you missed in that recitation of the equation. Y equals 4.93x minus 31.189. My slope is related to my x and my intercept. That's why those are the coefficients in my linear equation. A null hypothesis for an ANOVA. Well, it's either, I'm testing, are these related, right? If they were unrelated, then my slope should be 0. It wouldn't go up, it wouldn't go down. As we went from side to side, there would be no change. So your test here is testing to see whether or not this is 0. Look at the p-value, my slope. What was our alpha? 0.05. Do we keep the null hypothesis or do we reject it? We reject it. That means there is a correlation. And it's not 0. These are related. How strong a relation is it? Well, look at our confidence intervals. They even give me the 95% each way. They gave me the confidence interval. I don't have to do it. It's in there twice, by the way, because I specified that the confidence was 95. They give me the 95 all the time. And then the second set could be if you specify something else. So you said, I want a 99% confidence interval. The first two would be 95. The second two would be 99. Is 0 in this confidence interval? Another reason to reject the null hypothesis. The true slope should be between 2.5 and 7.36. And we came up with 4.93. Pretty good. Right in the middle there, right? We're 95% sure the answer should be between here and here, and 0 is not in there. Now, I could also do a one-tail test instead of a two-tail, equal 0 or not equal 0. Much harder to do in Excel, easier to do in other statistics packages, but I'm not going to do those here. The test statistic, t-stat, and t-crit, which isn't even shown, they just show me the p-value. T-stat there is the exact same answer we would get if we tested the R value like I showed you on Monday. That's the same calculation. Same t-score. All right, so what's left for me to do? What's left for me to do, figure out if I actually did look at a scatter plot, are any of those outliers weird? Do they lie outside my confidence intervals? It means I need to look at the residuals. How am I going to get all the residuals? Again, I'm not going to do this by hand. They will. We'll look at residual analysis on Friday because I've just hit the clock. I will see you all then. If you came in late and still have homework to give me, please come give it to me now. I expect to try and grade these this evening, and then I should have them back to you for Friday. The key will go up very shortly.